तर आज आपण पाहणार आहोत फर्मी एनर्जी अँड फर्मी एनर्जी लेवल, फर्मी एनर्जी अँड फर्मी लेवल, फर्मी डायरेक्ट डिस्ट्रीब्यूशन फंक्शन, position of Fermi level in intrinsic and extrinsic semiconductors. Fermi energy. Fermi energy, which refers to the energy of occupied quantum state in a system of fermions at absolute zero temperature. फर्मी एनर्जी म्हणजे काय तर एनर्जी ऑफ हायेस्ट ऑक्युपाइड क्वांटम स्टेट इन सिस्टीम ऑफ फर्मियन्स अँड ॲट ॲब्सोल्यूट झिरो टेम्परेचर. हायेस्ट ऑक्युपाइड क्वांटम स्टेट ची जी एनर्जी एखाद्या इलेक्ट्रॉनमध्ये जे आउटरमोस्ट शेल आहे शेलची एनर्जी, त्यामध्ये जे इलेक्ट्रॉन असतील त्यांची हायेस्ट ऑक्युपाइड क्वांटम स्टेट, त्याला आपण त्या लेवलला आपण त्या एनर्जीला आपण फर्मी एनर्जी म्हणतो. पण कधी जर ॲब्सोल्यूट झिरो टेम्परेचरला. फर्मी लेवल इज मेजर ऑफ एनर्जी इलेक्ट्रॉन विदिन अ सॉलिड. फर्मी एनर्जी अ मेजर ऑफ एनर्जी ऑफ लिस्ट टाइटली हेल्ड इलेक्ट्रॉन विदिन अ सॉलिड. एखाद्या सॉलिड मध्ये जो ॲटम आहे, एखादा ॲटम, त्यामध्ये जी बाहेरची आउटरमोस्ट शेल जी असती ती न्यूक्लियस कमी अट्रॅक्शन असतं. त्या शेलवर न्यूक्लिअर अट्रॅक्शन हे कमी असतं. त्या लेवलला आपण फर्मी लेवल म्हणतो. फर्मी लेवल इज मेजर ऑफ एनर्जी ऑफ लिस्ट टाइटली हेल्ड इलेक्ट्रॉन विदिन अ सॉलिड. ऑफ लिस्ट टाइटली हेल्ड इलेक्ट्रॉन. फर्मी एनर्जी is highest and lowest occupied single particle states in non-interacting fermions at absolute zero temperature. Fermi energy, highest and lowest occupied single particle state in quantum system temperature. फर्मी एनर्जी ही जी आहे ती एनर्जी डिफरन्स आहे बिटवीन हायेस्ट अँड लोवेस्ट ऑक्युपाइड सिंगल पार्टिकल स्टेट. म्हणजे हायेस्ट त्याची एनर्जी जास्तच असणार, जी न्यूक्लियसच्या जवळची शेल, इनरमोस्ट शेल, त्याची जी एनर्जी आणि जी आउटरमोस्ट शेलची एनर्जी डिफरन्स म्हणजे फर्मी एनर्जी. सिंगल पार्टिकल स्टेट क्वांटम सिस्टम ऑफ नॉन इंटरॅक्टिंग फर्मियन्स इंटरॅक्ट नाही होत, दोन वेगवेगळ्या शेल ॲट ॲब्सोल्यूट झिरो टेम्परेचर आणि ॲब्सोल्यूट झिरो टेम्परेचर पाहिजे. ओके. फर्मी एनर्जी classification of solids on the basis of band theory. Metal, semiconductor, insulator. Classification of band theory. No band gap in metal. Energy gap is zero. In semiconductor, the energy gap of 0.7 volt to 1.1 electron volt, and in insulator there is relatively highest difference in energy gap. in valence and conduction band. That is, energy gap is high relative. Energy gap in insulator is around nearly 5 to 10 electron volt. Probability distribution function. We are interested in the various energy levels at given temperature. We cannot apply Maxwell Bold distribution to electrons because they obey. We are interested in the various energy levels in a conductor at a given temperature. We cannot apply Maxwell Boltzmann distribution to electrons because they obey exclusion principle, and they are indistinguishable particles. They obey exclusion principle, and they are indistinguishable. The statistical distribution function application particles is the Fermi Dirac distribution function. The probability that an electron occupies an energy level E at thermal equilibrium is f of E is equal to 1 upon 1 plus e raised to e capital E minus E of upon kt. इथं एफ ई म्हणजे फर्मी फॅक्टर आहे. ई एफ इज फर्मी लेवल एनर्जी. E capital E means energy. K is Boltzmann constant. Its value is 1.38 into 10 raised to minus 23. T is temperature. F of E is Fermi factor. Remember, F of E is Fermi factor. And remember the formula. It is a probability that an electron occupies an energy level E at thermal equilibrium. Fermi factor is that probability that an electron occupies energy level E at thermal equilibrium. Formula is f of E is equal to 1 upon 1 plus e raised to e minus e f upon kt. F of E is equal to 1 upon 1 plus cap upon kt. F of E is 1 plus e minus e f upon kt. F of E is equal to 1 upon 1 plus e raised to capital E minus e f upon kt. F of E is f of t is 1 upon 1 plus e raised to capital E minus e f upon kt, where f of E is Fermi factor, e of f is energy of Fermi level, k is Boltzmann constant is its value is 1.38 into 10 raised to minus 23, and T is temperature, E is energy of electrons. Now we will discuss about Fermi direct probability distribution. Uh, According to this formula, we are discussing this topic, Fermi direct probability function. When t is equal to 0, for E is less than E of, Fermi level energy is less than energy of electrons. at that time when T is equal to 0 and Fermi level energy Fermi level energy is greater than energy of electron. F of E, that is Fermi factor, that is probability uh, probability that an electron occupies energy level E. एखादा electron, uh, that, uh, one electron is occupying energy level E. That F of E probability of that, then F of E is 1 when T is equal to 0 and E is less than EF. Case 2, T is equal to 0 for E is greater than EF. F of E is equal to 1 upon 1 plus capital E minus EF upon KT, where uh, we are substituting T is equal to 0 here, and at here E is greater than EF. Fermi level energy is less than energy of electron at T is equal to 0 for E is equal to EF. Sorry, E is greater than EF. F of E is 0. Similarly, T is for E is equal to EF. F of E is indeterminate. F of E is indeterminate. It is important. Remember, at T is equal to 0, F for E is equal to EF. E is equal to 1 upon 1 plus E raised to capital E minus EF upon KT. We are substituting T is equal to 0, and therefore, and also here E is equal to F. Therefore, it becomes form of 0 upon 0. Therefore, F of V uh, becomes indeterminate. Indeterminate. The and now fourth case, at T is greater than 0 Kelvin for E is equal to E. F of E is equal to 1 upon 1 plus E raised to. Therefore, but E is greater becomes 0 and 1 upon 1, that is 0.5. Remember this graph, F of E, F of E and E. When E is greater than EF, at T is equal to 0, here T is equal to 0. How did okay, remember that position of Fermi level. The Fermi function F of E is equal to 1 upon 1 plus E minus EF upon KT. All energy levels in energy EC and all energy levels in valence band have energy EV. Okay. Here, let is number of electrons in conduction band and NV is number of electrons in valence band. probability that as n is equal to nc plus nv, that is number of total number of electrons equal to number of electrons in conduction plus as total number of electrons in semiconductor is number of electrons in conduction band plus number of electrons in valence band. Therefore, n is equal to nc plus nv. Probability that there are nc electrons occupy energy state EC upon n. Probability that nc electron energy level energy state EC, that nc electrons occupy energy state EC. P of EC is equal to nc upon n. Now position of Fermi level according to Fermi direct distribution function, the probability of electrons in conduction band occupying energy level EC will be given by f of EC is equal to plus e raised to EC minus EF upon kT. As equations 3 and 4 represent the same probability. 3 and 4. And then we are equating f of EC and P of EC is equal to 1 upon 1 plus e raised to EC minus EF upon kT. Therefore, NC is equal to n upon 1 plus e raised to EC minus EF upon kT. Here, similarly for valence band, NC is equal to n upon 1 plus e raised to EV minus EF upon kT. From these two equations, from equation 2, as n equal to nc plus nv, putting the values of nc and nv from 5, equation 5 and equation 6, equation 5 and equation 6, we are adding equations for calculating uh, for whole the semiconductor. Therefore, n is equal to n upon 1 plus e raised to EC minus EF upon kT plus n upon 1 plus EV minus EF upon kT. Therefore, 1 is equal to 1 upon 1 plus e raised to EC minus EF upon kT plus 1 upon 1 plus EF minus EV minus EF upon kT. 1 plus e raised to EC minus EF upon kT into 1 plus 1 plus e raised to EV minus EF upon kT is equal to 1 plus e raised to EC minus EF upon kT plus e raised to EV minus EF upon kT. We are doing cross multiplication, uh, numerator and denominator. We are multiplying these two terms, and we are getting this. So after our equation becomes EF equal to EC plus EV upon 2. That is, value of Fermi level is equal to EC plus EV upon 2. Energy of Fermi level is equal to energy of conduction band plus energy of valence band energy of conduction band plus energy of upon 2. Yes. That is energy of the level middle of this middle the level and valence band. Okay. Energy of that level is Fermi energy level. That is Fermi level is equally at equal distance from conduction and valence band. Position of Fermi level. Position of Fermi level. The Fermi level in intrinsic semiconductors is exactly the middle of the forbidden energy gap. Yes, after this uh, taught here that thus Fermi level in forbidden energy gap. This is conduction band and this is valence band. The Fermi level is where Fermi level is here, which is from which is equal distant from conduction band and valence band. Right, EF is equal to Eg by 2. Eg means uh, energy of energy gap. This forbidden energy gap. Energy of forbidden energy gap divided by 2. We get Fermi level. Understood. Position of Fermi level in N type. In N type semiconductor. Position of Fermi level is where now we will discuss. At T is equal to 0 Kelvin in N type semiconductor.